Okay, so we are now looking at question 20 of the exam paper, and the reason I've done it on this spare sheet of paper is because this question has more than one way in which you can do it, and I wanted to explore both ways with you, show you an easy way and also a harder way. So let's start with the harder one first. But before we do that, let's read the question. So it says the only solution to x squared plus bx plus c equals 0 is x equals negative 15. Work out the values of b and c. So we're working out the coefficient of x, which is b, the number multiplied by x, and also that constant, which is just c. Okay, so it's just a normal number, and both are normal numbers in okay, and we're trying to figure them out. Now the way we can do it is, because we've got two unknowns, that should somehow ring a bell in us that we can use simultaneous equations. But how do we make two different equations to do the elimination method, or we can do the substitution method? Now I'm going to start by doing the substitution method, and I'll show you how. So they've given us a clue, x equals negative 15. So whenever they provide you with certain values, always try and see how you can use it. So x is negative 15. Okay, I can replace all the x's now with negative 15 because that is the only solution available. So let's go and plug it in. So I'm just going to write down sub for substitute. X equals negative 15 into x squared plus bx plus c equals 0. Now I'm just going to replace all the x's with negative 15. So we get negative 15 squared plus negative 15 x times by x plus c equals 0. So negative 15 squared is positive 225. And then we've got negative 15. Oh, it should have been a b, sorry, not an x. Okay, so negative 15b, and then a plus c equals 0. Okay, so that's our, you can see our first sort of equation that we've got there with the two unknowns b and c. Let's now try and find a different one, which we can then use these together to calculate the values of b and c. So another thing that they've kind of discreetly told you is the only solution. Okay, so that is a big deal. Going to put a circle around it, because the only solution, if you remember the quadratic formula and how we also look at discriminants. Okay, now in the GCSE spec, back in my time it wasn't the case, we did that in A levels, but the discriminant, if you do not remember, I'll just write down here, is that bit under the square root. So if I show you the whole quadratic formula, minus b plus minus square root of b squared minus 4ac all over 2a. This bit under my square root, okay, is, if I just put brackets around it, is the discriminant bit. Discriminant. That can be used to identify how many real solutions, if any, the quadratic equation has. So because they've said there's only one solution, we know that the discriminant should just equal 0. Okay, it can let me tell you the conditions, okay, that the discriminant can take to help us identify how many solutions there will be. So if that discriminant, so b squared minus 4ac equals 0, that means that there is just going to be let me just do an arrow, one solution, one real solution. If b squared minus 4ac is less than 0, okay, no solutions. If b squared minus 4ac is greater than 0, then there are two real solutions. Okay. So that is the discriminant and how we can sort of use that. I would really highly advise, if you don't remember that, to sort of take a screenshot, copy it in your notes somewhere, because this sort of stuff, if you didn't know that, it would have been hard for you to set up that equation. Know that we can now use this, b squared minus 4ac equals 0, to help us solve the question. Okay, so I'm going to use this first condition because they've already told us that there is only one solution. So let's do that. So b squared minus 4, and a in this case, if we don't know, is the coefficient of x squared, okay, the number being multiplied by x squared. Well, in this equation they've given us, there's nothing there, there's no way. That means that a is definitely going to be 1, okay. Oops, you can't see that. So a is definitely going to be 1 here, okay, the coefficient of x squared. So I'm going to replace my a with 1 and then times by c, which we don't know, equals 0. Now this just equals b squared minus 4c equals 0, okay? So it looks better now. So we've got one equation and we've got another equation going on over here. Now there are many different ways that you can use substitution here, okay, with these, and set up like a, you know, use the simultaneous equations method, sorry, to solve this system of equations. But the way I will go about it is that we can see we've got two c's. Now the b's I don't want to fiddle with because we've got b squared, and it will just make things a bit harder in terms of our calculation, okay. And this is also a non-calculator paper, if I remember. Yes, so it's best that we try and avoid hard calculation. So I'm just gonna make c the subject of this first equation. Okay, so therefore these little triangles just mean therefore. A bit of fancy mathematical notation for you all. Equals c equals 15b. So if I take everything onto my other side of the equation, rearranging equation, get 15b, take away 225 because it was addition there. So that's my first equation. I'm going to substitute that into my second equation. Okay, so that means I've got b squared minus 4 times by now c, which is 15b minus 225, still equaling to 0. Now if I go ahead and actually expand my brackets, I get b squared minus 4 times by all of this. So 4 times by 15b, negative 60b, minus 4 times a minus 225 is positive. So we've got a bit of multiplication to do here, but that should get us to 900 plus 900 equals 0. Okay, now you've got a familiar sort of quadratic equation for you to be solving. Okay, so finding two numbers that multiply to give 900, but add to give 60, negative 60, okay? That is, so I can straight away think about negative 30 and negative 30, because minus 30 gives us minus 60, but when you times them, you get positive 900. So you get b squared minus 30b plus 900 equals 0. So one solution for b, so b is just going to be positive 30, okay. That is that. Now what we need to do is we can just substitute that 30 back into one of my equations to then work out what c will be, okay. I'm just going to use equation 1 because it's easy, and c is already the subject. So therefore c equals 15 times by 30 minus 225. Yes, because 15 times 30 will give us our 400, minus 225 will just give you 225 again. So therefore, the values of b and c, b equals 30, c equals 225. Okay, and that is the question done. So you can see it's quite a long-winded way. That's one way to work it out. Another one is actually quite easy, which will make us think like, why did we do all of that? But it's good that we know both ways. So since we know that x is equal to negative 15, therefore that means that my factorized form should have looked like x plus 15 squared, okay, or x plus 15 times by x plus 15. Since there's only one solution, okay, which is x equals negative 15, my actual factorized form for this quadratic would have looked like this, okay. So if I go ahead and actually expand this now, I can work out the answer to what b and c will be, the coefficients of x and just the positive c. So if I expand this, I get x times x is x squared, x times 15 is plus 15x, 15 times x is plus 15x, 15 times by 15, it's just going to be a 225. Simplifying this gets us to plus 30x plus 225. And it's as simple as that. There's your b. And this is your constant c. Okay, so that was a fairly much easier, simpler way. But that's the two ways that we can do it. Okay, just label that as method 2. The easy way. Okay, and that is question 20.